Assalamu alaikum students. In the previous lecture basically we have studied method of undetermined coefficients, and in that we have studied when the particular solution g of x is of the type constant or linear, quadratic or cubic or exponential or trigonometric, then we can have a basic trial particular substitution for those type of functions. Today we will study the annihilator approach, and first of all we have to study the differential operators. So for differential operator, I think that you know already what is a differential operator. So in calculus, differentiation is often denoted by the letter d, and we can also write it as dy by dx equals to d of y. So that is called a differential operator, and it transforms a differentiable function into another function. Like for example, you have d of e to the power 4x. So what will be the derivative of e to the power 4x? That will be 4 into e to the power 4x. Simply, if you apply the differential operator as on the function 5x3 minus 6x square, and when you apply the differential operator, that will become 15x square minus 2 into 6 is 12x. So that will be its derivative. Also, for the trigonometric function, if you apply the differential operator on cos of 2x, then what will it become? It become minus sine 2x, and what will be the derivative of 2x? That will be 2. So it becomes minus 2 sine of 2x. So this is the differential operator, and it possesses the linearity property. It is linear. If you in the linear combination, it can be applied like if you have this constant, and if you have a function, and if you apply this differential operator, then c cannot be affected by the differential operator. So that will be df of x. Simply also if you have f of x plus g of x, two different types of functions, so it is a linear operator. That means that it can be applied separately. Plus minus means it can be applied separately. So this is the differential operator, and it is a linear differential operator. Okay, so for the higher derivatives, if you apply this differential operator, so if I generalize, if it is a first derivative dy by dx, and if I generalize this, if you have like n derivatives, so if I write it as dny by dxn, so what will be its differential operator? Its differential operator will definitely be dn of y. So this is a higher order or nth order differential operator. Also, if it is d plus 3, so d plus 3 means dy by dx plus 3. And also if you have first example, second example, if you have, so in the second example, if you have d square plus 3d minus 4, like in this, then it definitely means that y double dash plus 3y dash minus 4y or d2y by dx square plus 3dy by dx minus 4 into y. And third example is, if it is 5d cube minus 6d square plus 4d plus 9, so that definitely means 5d cube d3 of y by dx cube minus 6d2 by y by dx square plus 4dy by dx plus 9 into y. So that is called a linear differential. If you have like second order differential equation, that is given by a y double dash plus b y dash, that is basically an auxiliary second order differential equation with constant coefficients, plus c into y equals to g of x. If you have this type of equation, second order linear differential equation, then how can you write this equation in terms of the differential operator? So I am writing here, it is equivalent to a d square plus b into d plus c into y equals to g of x, right? So this is the differential basically operator, and if I substitute this all term, if I defined it as L is, we can call it a new operator because it is a combination of differential operators, and we can call it a new operator. So if I suppose that L is equal to a into d square plus b into d plus c, so that means that L of y equals to g of x. So that means the operator is said to be second order linear differential operator with constant coefficients.